Good evening to all. This is my first video I posted here. I going to post that several engineering subject videos in that channel. So please support me. Now we go for this first class. We going to see about the spectrometry. Here we see that what are the types of spectrometry and the what first we going to see about what is spectrometry, and also that what are the components inside the spectrometers and what are the uses of the spectrometers in the several industries. Okay, then first we go for what is spectrometry. The spectrometry is a scientific method based on the absorption of light by the substance and takes advantages of the two laws. Here we mention the two laws for the basic principle of the spectrophotometry. Here we see that this is the first law, the Lambert's law. The proportion of light absorbed by the medium is independent of the intensity of incident light. A sample which observes the 75% of the light will always observe the 75% of the light, no matter the strength of the light source. This is the first law of the spectrometer, that is called the Lambert's law. Here we see that the Lambert's law is expressed as I divided by I naught is equal to T, where I is equal to intensity of transmitted light, I naught is equal to intensity of the incident light, T is equal to transmittance. This also allows the different spectrometers with different light source to produce the comparable absorptions readings independent of the power of the light source. Next law, we go for that Beat's law. This also the principle of the spectrometry. The absorptions of the light is directly proportional to both the concentration of the observing medium and the thickness of the medium. Here we see that the absorptions of the light is directly proportional to both the concentration of the observing medium and the thickness of the medium. In spectrophotometry, the thickness of the medium is called the path length. Here we see that GE Healthcare offers a variety of instruments and accessories which allow the measurement of path length from 10 cm down to 0.2 mm. This graph represented that it's draw between the path length and this absorbance. Here we see that the absorbance of the light is directly proportional to both the concentration of the observing medium and the thickness of the medium. This is a Beat's law. The Lambert's law and the Beat's law is the main principle of the spectrophotometry. Here we see that these are the components included in that spectrophotometry. The spectrophotometry, first we go for the light source, next monochromator, and next the adjustable aperture and sample and the photoresistor, amplifier and display. These are the components inside the spectrophotometry. First we go for the light source. Before we see that the spectrometer range. Here we see that the spectrometer have the different range of types. First we see that the ultraspec, that is the ultraspec 9000, the variable bandwidth, advanced application and the method developments, and the ultraspec 8000, the Faramatipio compatible dual beam analysis. These are the spectrometers. They are used in several applications. Several range of spectrometers are available in the market. These are the components of the spectrometer. We see that this is a sensing part of this spectrophotometers, and this is a light source, and this is the sample compartment, and this is a monochromator. The monochromator is act as a filter. It used to filter the light from the light source. Okay, the monochromator is used to filter the light rays from the light source. It allows only the particular length of wavelength of lights only allowed to out. Here first next we go for the light source to provide the sufficient of light which is suitable for marking a measurement. Here we see that the three types of light source are used: tungsten lamp, hydrogen lamp and xenon lamp. These are the three lamps we are normally used for light source. First we go for the tungsten lamp. It is the most common light source used to spectrophotometer wavelength. The range of about 330 to 900 nanometer. It has the long life about 1200 hours. Next go for the hydrogen lamps. Hydrogen or the deuterium lamps. For the ultraviolet region, the hydrogen or deuterium lamps are frequently used. The range is approximately 200 to 450 nanometer. Deuterium lamps are generally more stable and has long life, about 500 hours. This lamp generate the continuous or discontinuous spectral. This image we see that this is a hydrogen or deuterium lamps. And next we go for the xenon flash lamps. The xenon flash lamps have the several advantages as the following. The range between 190 nanometer to 1000 nanometer, emit both UV and visible wavelength. It have the long life, do not heat up the instrument, reduce warm up time. These are the advantages of the xenon flash lamps. Next we go for dispersion devices. The dispersion devices causes a different wavelength of light to be dispersion at a different angles. The types of dispersion devices used are prism or filters. These are the mainly used dispersion devices in the spectrophotometer. Next we go for what is prism. Prism is used to isolate the different wavelength. Prism may be made of glass or quartz. It used to split the light rays from the light source. Filters. Filters we are already know what are the operation of filters. The filters separate the different parts of the electromagnetic spectrum by absorbing or reflecting certain wavelengths and transmitting other wavelengths. Absorption filters are the glass substrates containing absorbing species that absorb certain wavelength. A typical example is cut on a color filter which blocks short the wavelength light and transmit longer wavelength. Next, absorption cells, cavities. A cavity is a kind of cell, usually a small square tube, sealed at one end, made of plastic, glass or optical grade quartz, and designed to hold the samples for spectroscopic experiments. These cavities are mainly used to hold the samples in the photo spectrometers. Next we go for the detectors. Detectors is the heart of the spectrophotometers. Detectors is used to convert the any physical signals into the electrical signals. Here we are using the light rays, and the light rays is to be converted into the electrical signals by using these detectors. Any photosensitive device can be used as a detector for radiant energy. The photocell and the phototubes are the simplest photo detectors, producing current proportional to the intensity of light striking them. Here we are using the detectors. It's generating the current. It's proportional to the light striking on them. Next we go for the display devices. The data from the detectors are displayed by a readout device, such as an analog meter, a light beam reflected on a scale, or a digital display or a liquid crystal display. The output can also be transmitted to this computer. The display devices have the two types of display devices we are normally used. One is the analog and another one is digital. The analog means that value is to be displayed in it by using the needle and scales. And the digital display means the value will be displayed in a screen and is to be directly connected to this computer. So these are the display devices here we are using in that photo spectrometer. Next we go for uses of spectrometer. To determine the absorbance of transmission of characteristics wavelength of radiant energy by a chemical spices in solution. Here the spectrophotometry is used to find the chemical particles in that food or any industrial products. Identify organic components by determining the absorption maximum. Used for color determination within the spectral range. Here we are using this spectrometer is used for the color determination within the spectral range. These are the uses of the spectrophotometer. Thank you.